Okay, so now we're going to talk about limiting reactants and percent yield, all right? This is the crowning achievement of our work in balanced chemical reactions. All right, so first of all, imagine if you have a peanut butter sandwich, and let's suppose it's a simple sandwich. It needs 2 slices of bread and 1 tablespoon of peanut butter, how much ever that is. 1 tablespoon of peanut butter and 2 slices of bread. Then you're going to have to ask yourself, how many sandwiches can I make if I have 20 slices of bread? Right? And so in this week, we ask this question at my house all the time. How many sandwiches can I make if I have 20 slices of bread? Okay? So, well, then I go to the cupboard and I find I only have 1 tablespoon. Well, if I only have 1 tablespoon, I can only make one sandwich, right? What if I have 4 slices of bread and I have a full jar of peanut butter? Well, then I can make 2 sandwiches, right? You see what I'm doing here? This is the math we're going to be doing in this section, all right? So our learning goal is to identify a limiting reactant when given the quantity of 2 reactants. Calculate the amount of product formed. We're going to calculate the amount of product formed from the limiting reactant. And we're going to give the actual quantity of the product and calculate a percent yield. We'll talk about that in a minute. All right, so first of all, a limiting reactant in a chemical reaction, just like the peanut butter and the slices of bread, is the substance that's used up first. The limiting reactant is the substance that's used up first. It limits the amount of product that can form, okay? The reactant that does not completely react and is left over is called the excess reactant. All right? So our core chemistry skill here is calculating the quantity of a product from a limiting reactant. All right, so in many reactions, there's a limiting reactant. This is how we build our reactions as chemists that determine the amount of product that can be formed. Given a chemical reaction, from each reactant, we can calculate the amount of product possible, and we can determine the limiting reactant, that is the one that runs out first. Okay, so let's do an example. So here's an example. Let me come over here with my pencil. And when I do this, I'm going to encourage you to do the same thing. I'm going to say, all right, if I've got 3 moles, I'm always going to set up a table here. Set up a table. Moles. And I'm going to write it out. You should do the same. Follow my example. Moles. If I've got 3 moles of carbon monoxide and 5 moles of water, or H2, sorry, how many moles of methanol can I make? So what I'm going to do is I'm going to set up an arrow like this and an arrow like this. And that is if I can use all of these moles of hydrogen, how much methanol can I make? And if I can use all these moles of carbon monoxide, how much can I make? So this is going to be moles of H2. Whoops, just a second here. Moles of H2. And I know, you know what I'm going to do? It's going to be very busy there. I'm going to call this methanol. I'm going to call that methanol, okay? So it looks like I've got 2 moles of hydrogen for every 1 mole of methanol, and I got 5 moles starting out, so my hydrogens cross off, and this is going to give me 5 halves moles of methanol, okay? But if I instead use these 3 moles of carbon monoxide, let's cancel this out with the picket fence method. Carbon monoxide and methanol. It looks like from the balanced reaction, these are 1 to 1. And I had 3 to start out with. So it looks like if I can use all my carbon monoxide, I can make 3 moles of methanol. Well, it looks like I'm going to run out of my hydrogen first, right? It's the smaller number. So I'm going to circle that and say, this is the maximum I can make because I don't have enough to make 3 moles, right? I'm going to run out of my hydrogen first. That's the limiting reactant, okay? So the question is, how much can be produced? It's here. And what's the limiting reactant? It is here. All right. So let's do one more, but this time we're going to do it with mass. All right. Now, if we do it with mass, then we have to convert to moles because the moles are the only relationship that we know. We know the moles, we know the molar-mole factors from the balanced reaction. We don't know mass to mass. So when I'm given a question with masses, I have to convert to moles first. All right, so let's go here and do this problem. Suppose that we have silicon dioxide. All right, you know what I'm going to do? I'm going to insert slide, and I'm going to work on, I'm going to come here, I'm going to take that. And C, I'm going to come over here and put it on a blank slide, and V. All right, this gives us a little more room to work, okay? So let's get rid of that. Let's make this a little bit bigger. Make this bigger. Make this 32. Okay. Now, this will give us some room to work. Let's go over here to draw. All right. So, if I have, let's go back to the slide and see how much we had. Looks like we had 70 grams of silicon dioxide. So, I'm going to set my table up here, right? Like I said, silicon dioxide, that was a mass. This was in grams, and it was in 70, right? 70 grams of silicon dioxide and 50 grams of carbon, 50 grams. Now what I've got to do is I've got to do my molecular weight, or my molar mass, which is in grams per mole, of silicon dioxide and carbon, okay? And then I can get my moles, and then I can do my L's, okay? So silicon, I know carbon is 12 grams per mole, but I don't know silicon dioxide. So I'm going to come to my periodic table. Oh, so tempting to just Google that, isn't it? See that? Periodic table, but I'm not going to do it with Google. I'm going to go here, and I'm going to say silicon is 28.085. Silicon is 28.085. Plus 2 times carbon, or 2 times oxygen, which is 15.999, is equal to, I'm going to do this in my calculator here, which you cannot see, so you can take my word for it, I'm not Googling it, 28.085 plus 2 times 15.999, 32 plus 28 is 60, so this ought to give me something close to 60, and it does, okay? 60.083. How do you spell 60? 0.083. Okay, and this is 12.011. Okay? Because we just looked it up in the periodic table. So the moles then is going to be 70 divided by 60. 70 divided by 60 equals 1.165. 1.165 ... and 50 divided by 12, 50 divided by 12 is equal to 4.167. 4.1666. Repeating, right? Okay, so now I'm ready to do my L's, okay? The question is, how much of something else can I produce? I'm going to set up my 2 L's here, calculate it, and what was the question? How many grams of carbon monoxide are formed? So it's the carbon monoxide I'm looking for. So I'm going to come over here and say carbon monoxide. Carbon monoxide is what I'm looking for. And then this is from silicon dioxide. Right? And my molar ratios are what go right here. It looks like there's 2 moles of carbon monoxide for every 1 mole of silicon dioxide. Oops, that wasn't supposed to be silicon dioxide. That was supposed to be something else. That was supposed to be carbon, right? And that's 3 moles of carbon, which I'll write the carbon in a second. But 2 and 1. right? That was carbon. This is my carbon. And let's go back to blue now. And it's 1.165 It's times 2, I guess, right? And then the carbon was 4.167, right? 4.167 times 2 divided by 3 equals 2.777. Just a second here. Sorry about that. 2.77. Let's just round to 8. And clear 1.165 times 2 equals 2.33. 2.33. So this is my lesser of the two. And so that is apparently the maximum amount of carbon monoxide that I can form. So I'm going to go over to this column here, and I'm going to put it right here. 2.33, right? And carbon monoxide is 12.011 plus 15.999 equals, because there's only one atom of each of those in there, right? 12.011 plus 15.999 equals 28.01. 28.01. I'm going to multiply that times 2.33, and I get 65.26. So it looks like I can only make 65.2633. I can only make that much before I run out of silicon dioxide. Okay, that's my mass. I think I answered the question. How many grams of carbon monoxide are formed? Yes, and it is 65.26. All right, so we're going to do the learning check, I think, in the next video, because this video is starting to stretch out to a long. We'll do a learning check, and then we'll go on to the next topic in the next video.